Top-down and bottom-up design. In this video, we are going to see about top-down and bottom-up design. There are currently various approaches and tools available for the system design. The designer has to decide his or her overall approach for designing and selecting the tools and techniques to be used. Design starts from the system flowcharts. Starting from this, the output and input formats are depicted on layout charts for validation with the user. The process description are written using narrative and depicted decision trees, decision tables, and flowcharts. In structured design, the logical and physical data flow diagrams of the new proposed system are used as a starting point. Classification of forms. In this video, we are going to see about classification of forms. People read from forms, write on forms, and spend hours handling forms and filling forms. The data the forms carry come from people and the informational output goes to people. Form is a tool with a message. It is a physical carrier of data of information. It is either an authority for action or a request for action. A printed form is generally classified by what it does in the system. There are three primary classifications: action, memory, report. Action. This type of form requires the user to do something. For example, purchase orders. Memory. This form is a record of historical data that remains in a file, is used for reference, and serves as control on key details. Examples are inventory records, purchase records. Report. This form guides supervisors and other administrators in their activities. It provides data on a project or a job. Examples are profit and loss statements, sales analysis report. Requirements of form design. Form design follows analyzing forms. Since the purpose of a form is to communicate effectively through forms design, there are several major requirements. Identification and wording. The form title must clearly identify its purpose. Columns and rows should be labeled to avoid confusion. The form should also be identified by firm name or code number to make it easier to reorder. Maximum readability and use. The form must be easy to use and fill out. It should be legible, intelligible, and uncomplicated. Ample writing space must be provided for inserting data. Physical factors. The form's composition, color, layout, and paper stock should lend them to easy reading. Pages should be numbered when multi-page reports are being generated for the user. Order of data items. The data requested should reflect a logical sequence. Related data should be in adjacent positions. Data copied from source document should be in the same sequence on both forms. Ease of data entry. If used for data entry, the form should have field positions indicated under each column of data and should have some indication of where decimal points are. Size and arrangement. The form must be easily stored and filled. It should provide for signatures. Important items must be in a prominent action on the form. Use of instructions. The instructions that accompany a form should clearly show how it is used and handled. Efficiency considerations. The form must be cost-effective. This means eliminating unnecessary data and facilitating reading lines across the form. Types of report. Executive summary, intermediate managerial information supporting data. The user requirements for each type determine the final form design. Carbon paper as form copier. Carbon paper is one way of duplicating information in a form. There are two types of carbon classified by the action they encounter. Glide action, hammer action. Glide action carbon. It is inserted between a set of forms. It allows the glide action of the pencil to transfer dye to the surface of the sheet beneath. Hammer action carbon. It is used in typewriters and line printers of computers. The hammer action of the keys transfers the carbon coating to the sheet beneath. Various methods of transferring impressions between copies are as follows. One-time carbon. It is made of inexpensive craft text paper. It is interleaved between two sheets in a form. It is used once and then thrown away. It is the most cost-effective for multi-part forms. Carbon-backed paper. The back of each form copy is coated with carbon, which transfers data to the copy beneath. NCR, no carbon required paper. The top sheet is chemically treated with invisible dye, which allows impressions to be transferred to the next lower copy. It is the cleanest and the costliest method. Erasing removes the coating permanently. The readability of the carbon copies depends on the color and outline. In multiple copies, the copies below the original should be lighter in weight for easy transfer of the carbon. Generally, one-time carbon is preferred when a small number of copies are required. If carbon is unacceptable, NCR can be used. Input forms design. In this video, we are going to see about input forms design. Inaccurate input data are the most common cause of errors in data processing. Errors entered by data entry operators can be controlled by input design. Input design is a process of converting user-originated inputs to a computer-based format. The information for the input design is obtained from the data flow diagram and the system flowchart. Input data. The goal of designing input data is to make data entry as easy, logical, and free from errors as possible. In entering data, operators need to know the following: the allocated space for each field, field sequence which must match that in the source document, the format in which the data fields are entered. For example, filling out the date field is required through the edited format DDYY. Source documents. Source data is initially captured on paper or a source document, for example, a check written against an account. Source documents can be entered into the system through punch cards, diskettes, or through keyboards. Features should be logical and easy to understand, should be clear, should specify to the user what to write and where to write. Input media and devices. Source data are input into the system in a variety of ways. The following media and devices are suitable for operation: punch cards, key to diskette, MICR, mark sensing readers, optical character recognition OCR, optical barcode, cathode ray tube CRT. Punch cards. Punch cards are either 80 or 96 columns wide. Data are arranged in a sequential or logical order. Operations use a key punch to copy data from source documents onto cards. This means that the source documents and card design must be considered simultaneously. Key to diskette. Key to diskette is modeled after the key punch process. A diskette replaces the card and stores up to 3,25,000 characters of data equivalent to the data stored in 4,050 cards. Like cards, data on diskettes are stored in sequence and in batches. MICR. MICR translates the special fonts printed in magnetic link on checks into directed computer input. Mark sensing readers. Mark sensing readers automatically convert pencil marks in predetermined locations on a card to punched holes on the same card. Optical character recognition OCR. Optical character recognition OCR readers are similar to MICR readers, except that they recognize pencil, ink, or characters by their configuration rather than their magnetic pattern. They are often used in remote locations as freestanding input preparation devices or direct input media to the system. Optical barcode. Optical barcode readers detect a combination of marks that represent data. The most widely known system is the Universal Product Code UPC, which codes retail items in stores. Automatic tag reading is a major breakthrough in speeding up customer service and eliminating costly data input errors at a point of sale. Cathode ray tube CRT. Cathode ray tube CRT screens are used for online data entry. CRT screen display 20, 40 or 80 characters simultaneously on a television-like screen. They show as many as 24 lines of data. In addition to determining record media, the analyst must decide on the method of input and the speed of capture and entry into the system. Processing may be batched, a group of records handled as a unit. Online, records that are processed directly. Sequential, sorted records. Random, that is unsorted records. Online data entry. CRT screens are used mostly for online data entry. As terminal prices decline and microcomputers are commonly used, entering data directly through the keyboard is becoming popular. Examples: automated teller machines, ATMs in banking, point of sale, POS in retailing. Online data entry makes use of a processor that accepts commands and data from the operator through a keyboard, touch-sensitive screen, or a voice input. The input is analyzed by the processor and is accepted or rejected. There are three major approaches for entering data into the computer: menu, formatted forms, prompts. Menu. A menu is a selection list that simplifies computer data access or entry. Instead of remembering what to enter, the user chooses from the list of options and types the option letter associated with it. A menu limits a user's choice of responses but reduces the chances for error in data entry. Formatted form. A formatted form is a pre-printed form or a template that requests the user to enter in appropriate locations. It is a fill-in-the-blank type form. The form is flashed on the screen as a unit. The cursor is usually positioned at the first blank. After the user responds by filling in the appropriate information, the cursor automatically moves to the next line and so on until the form is completed. During this routine, the user may move the cursor up, down, right or left to various locations for making changes in the response. Prompt. In prompt, the system displays one inquiry at a time, asking the user for a response. After giving response, the system will again display another inquiry, asking the user for a response. Most systems edit the data entered by the user. Crt Screen Design. Many online data entry devices are CRT screens that provide instant visual verification of input data. The operator can make any changes desired before the data go to the system for processing. CRT screen is actually a display station that has a buffer for storing data. A common size display is 24 rows of 80 characters each or 1920 characters. There are two methods for entering data on CRT screens: manual method, software utility method. Manual method. The manual method uses a worksheet similar to a printout chart. The menu or the data to be displayed is blocked out in the reserved areas. Example, in database, the command to print hello in the 10th row and the 10th column is as follows. At 10:10, say hello. Software utility method. This method designs screen layouts through software utility. Example, IBM provides a screen design aid (SDA) package that allows the designer to modify the display components. The main objective of screen display design is simplicity and accurate and quick data capture or entry. Some of the guidelines to be followed are: use the same format throughout the project. Allow ample space for the data. Overcrowding causes eye strain. Provide help or tutorial for technical terms or procedures. Output form design. In this video, we are going to see about output form design. The first step in system design is to design system outputs as per requirements within predefined guidelines and strategies. In output design, emphasis is on generating a hard copy or a soft copy of the information requested in a predefined format. The sources from which outputs are derived in an information system or input data, logical file records, and associated computations. These sources are to be taken into account in addition to the timings of the required output, the receipt of source data, the updating of logical files, and the demands of the system's environment. Understanding the type and purpose of the output is also essential. The output design implies identifying specific outputs needed to satisfy the information requirements, selecting methods for presenting requisite information, creating document report containing the required information. The following factors are considered in output design: content, format, frequency, medium, distribution. Content. Though it is determined during the information analysis, it may undergo minor changes during the design phase. Format. It deals with such issues as columns and row headings on reports, spacing, graphic displays, etc. Frequency. The frequency of output may be daily, weekly, monthly, or continuous. Medium. The output medium may be paper, pre-printed forms, video displays, or some combination of these and other media. Distribution. This aspects of output design deals with specifying who will receive the output and how many copies are to be made. Objectives of output. The output from an information system should accomplish one or more of the following objectives: convey information about past activities, current status, or projections of the future. Trigger an action. Signal important activities, opportunities, problems, or warnings. Confirm an action. Provide answers to the queries. Good systems output design is developed keeping into consideration the services it will be expected to offer to the organization and its users. The design process itself begins when the system analyst identifies the output the system must generate, a process that starts during requirements determination. An analyst often develops display screen outputs in application prototyping in order to allow the users to react both to the content and form of the output. Similarly, under the structured analysis method, DFT prepared earlier in the development process focuses on the nature of the output needed. Each data flow carries information that is either used elsewhere in the system or that leaves the system as external output. Types of outputs. The uses of output generated by a computer can be varied. For example, to a computer manufacturer, a computer using firm is a user. To the computer services section of an organization, anyone external to the section who receives output from the computer is a user. The term end user or end customer is used for the users who are farthest from the system. Output can be categorized as follows: external outputs, internal outputs, computer operation outputs. External outputs. These outputs are received by entities outside the organization, for example, invoices, orders, etc. Special attention is given to the format, content, and organization of these kinds of outputs as they directly have a bearing on the organization's business relations with its customers. Internal outputs. These outputs are received by people within the organization require careful consideration because they may affect the operational efficiency of the system. Computer operations outputs. These outputs are used within the computer services department, for example, usage statistics, control reports, etc. Depending on the circumstances and the contents, the output may be displayed, printed, or stored. Formats of output. In this video, we are going to see about formats of output. To make the user to focus their attention on the important feature of information in the output, it is necessary to present the information effectively. The presentation of information determines whether the output is comprehensible and readable. This gives guidelines for presenting tabular and graphical information, the use of icons, and strategies to use colors. Tabular format. Tabular information presented in row and column format is recommended to present details when few explanations are needed. In general, end users are most accustomed to receiving information in a tabular format. Accountants and those who regularly review financial data rely almost exclusively on tabular information, a row and column format. Common examples of tabular report are inventory control, accounts payable, and general ledger. The tabular format should be used under the following conditions. Few narrative comments or explanations are needed. Details can be presented in discrete categories. Each category must be labeled. Totals must be drawn or comparisons made between components. Some type of information becomes more visible and clear when presented in a tabular format. The user should distinctly be able to make out the following items in the output given in the tabular format. Exceptions as against the normal entries. Major categories are group of activities or entities. Summaries of major categories or activities. Unique identification information. Time-dependent entities. Tabular format helps to present the information in a meaningful order, chronological, alphabetical, etc. For example, highest to lowest value, zip code sequence, etc. This format allows us to put too many details on a report, resulting in overcrowding. In fact, one of the most frequent user complaints is too many details, too little information. Managers say they are drowning in data but starving for information. The first concern in designing output should be to ensure that unnecessary details are eliminated. The next should be to select features that will further enhance readability. Graphical format. Graphic systems are available across a wide range of prices and capabilities and for personal computers up to mainframes. Business graphics is not itself a new area, as management presentations have been enhanced by graphics and visuals for a long time. However, it is an area in the computer information system that is being used largely because powerful and economically feasible computer software is available that uses data from existing databases and generates high-quality charts and diagrams. The graphic forms can be shown on video display screens prepared in several colors on low-cost printers, drawn by computer-driven plotters, or produced on color slides using film recorders connected to the computer. These capabilities are available on personal computers for a small investment, as well as in mainframes where a full range of cost alternatives are available. For those users who are employing graphics to the best of its advantage, it considerably enhances their information presentation, but many presentations suffer because the graphics are poorly used. Some managers are willing to accept computer-generated graphics as a replacement for traditional reports. Types of business graphics. Business graphics makes use of various kinds of charts and maps. Pie chart. Pie chart describes relative proportions or contributions to a whole. For example, a firm wishing to describe the percentage of expenditures allocated to manufacturing applications can show how the percentage compares with other categories through a pie chart. Area chart. Area chart shows changes in performance along a scale over multiple time periods. A horizontal scale indicates time, days, months, years, and a vertical scale measures the units of interest, dollars, percentage, or number of units. Several times overlaid on the same chart enable the reader to see the change in one item compared to others. For example, displaying the increase in expenditures for manufacturing systems, marketing systems, and personal applications on the same curve that emphasizes the overall trend in expenditures, while it indicates which category of expense had the greatest change. Line chart. Line chart is frequently used to plot data that is continuous rather than discrete. These charts illustrate a trend over even intervals of time. For example, plotting sales as a line chart may let the user spot trends over time. Column chart. Column chart is used for displaying discrete data as opposed to continuous data. The columns can be stacked on top of each other. Bar chart. Bar chart is like a column chart that has been rotated 90 degrees to the left. The bars can be stacked from left to right. Maps. Maps can effectively show variations across geographical areas. Weather maps frequently show differences in temperature, precipitation, or sunshine. Computer-generated maps are equally effective to show sales or market penetration. The chart should be annotated to indicate the scale used, the meaning of each line or shape, and what the chart represents. Business graphics supplement other information, they do not replace it. Business graphics enable the users to get a quick idea of the issue under consideration. Standards in design of graphics. Standards not only assist the designers in preparing graphic representations, but they also help the user in interpreting the data. Most organizations have standards that specify how to design graphics output. All graphic outputs contain text, the design of which is as important as the other aspects of the output. Each graphic report, whether printed or displayed, should include a title and the date of preparation. For a series, page numbers are also important. Because text data will take longer to read than graphics, placement and legibility of labels should be given due consideration, taking care to avoid excessive details in grid scales. Consistent spacing in all labels and using a common family of fonts, type styles, maximize readability. Labels can considerably increase the accuracy with which people read data in bar graph form. However, the placement affects readability. Data values should be placed at the end of bars. All vertical and horizontal axes should be proportional, as should be their labels. Bold and italics type or underlining can be used to emphasize keywords or phrases. The use of capital letters in long words, titles, or footnotes impedes readability and thus should be avoided. Abbreviation should not be used. Using a common type of font assures consistency of graphic pages and displays designed by the different system analysis. Using the right fonts also influences legibility of text information. Use of icons. Icons are pictorial representations of entities described by the data. For example, a picture of an automobile may be used in reporting new car sales over 5 different years. Icons are now commonly used in computer interfaces to represent documents in baskets, file drawers, and printers. They have been used by graphic artists for many years when reporting data in newspapers, annual reports to stockholders, and in sales presentations. The following guidelines suggest when and how to use icons in system design. Select icons such that the prospective user is able to easily relate with. The icon should be recognizable and the user should be able to understand it immediately. If there is no familiar icon for situation, use narrative labels. Avoid requiring users to learn and remember unfamiliar symbols or images. Use the same icon to represent identical concepts. Avoid labeling icons. Maintain a common size among various types of symbols. Color representation. There is an upsurge in the color facilities available with both large and small computer systems. However, as with graphics, improper use of color obstructs rather than assists user and management productivity. Color should enhance, not replace good output design. In fact, a good practice for analysis is to first design the output in the best form possible. Only then should the use of color taken into account. In general, it is suggested that 4 or fewer colors should be used to prevent information on a screen or report. If information is displayed visually, less can be shown clearly when few colors are used than when only 2 are included in the design. The analyst must take care to maintain consistent color usage throughout the output and reports for a system. Green and blue are best for depicting normal situations. The brightest colors emphasize the most important information on a display screen. Bright colors include white, turquoise, and pink. Dark colors include magenta, red, green, and blue. Designing printed output. In this video, we are going to see about designing printed output. It is important to neatly design printed output as in many cases, they are the only means of interaction between end users and the data processing system. The layout and content should be clear and comprehensible. System analysts use printed output when they need to mail a document to a customer or supplier, print a record of data or a report of information, or circulate a large volume of information to several persons simultaneously. Only those reports whose printing is absolutely necessary should be printed. One well-designed report may sometimes replace several poorly designed ones. Providing unnecessary details assists no one, so analysts should eliminate unnecessary details from the printed output. The most common medium for computer outputs is paper. Though many organizations have opted to use film, microfilm or microfiche as an output medium to overcome the data storage problem, the importance of paper cannot be determined. The paper is comparatively easy to use as the use of film requires special equipment. Several media devices are available for providing computer-based output. Some of these are magnetic ink character readers (MICR), printers (dot matrix, inkjet, laser), computer output on microfilm (COM), visual display units (VDU), graph plotters, audio response, printers and printed reports. The various types of printers are briefly listed in the following table. Printer reports vary in size, although analysts often use the following standard sizes: 9.5 by 11 inches, 11 by 14 7 by 8 inches, 8 by 14 7 by 8 inches. These sizes are for continuous forms, sometimes called pin-fed or fan-fold forms, connected sheets of paper that are fed into printer one after the other. All the features of printed output are available in microfilm and microfetch, the two film output methods. Film output reduces output cost by approximately 1/3. After developing in the microfetch machine, film can be stored and retrieved when required. For reference data used infrequently, microfilm could be a useful output option. A page of output takes very little space when stored on a microfilm. 1 square inch of a film can store as much information as several pages of paper report. A 3 by 5 inch card stores the equivalent of hundreds of pages. The time taken to locate the film reel or card containing the required information and to load the film into a microfilm or microfetch reader for viewing is a real disadvantage. The user should maintain a proper index to find the required film from among the several stored film reels. Pre-printed forms. Reports could be printed on a simple paper, but usually when an organization sends a report to its customer, the logo and the name of the organization is also printed on it. Sometimes the report is printed on a paper which is pre-printed. Recall your high school mark sheet. The name of the board, the year, and the logo of the board as well as the name of examination passed were printed on the paper. The marks, name, school name, date of birth, etc. were printed afterwards. Another example is your electricity bill. The titles of various labels are pre-printed. The values against them are printed by the information system. Multiple copies of output. Organizations often need more than one copy of a document or report prepared by the computer. There are several ways to produce multiple copies, such as repeated printing of the report, especially easy and economical with laser printing, or the use of an office photocopier. Among common and cost-effective ways to produce multiple reports is to specify a multi-part form which automatically produces duplicate of the original copy. There are two types of multi-part forms: carbonless copies, interleaved carbon copies. Carbonless copies. Multiple copies using carbonless papers are possible because of a special chemical coating on the backside of each copy except the last. Writing or printing on the original carries through to the copies. The coating causes the image to appear on the copies underneath. Interleaved carbon copies. Carbon paper is suitable for one-time use is interleaved between each sheet of paper. Turnaround documents. If the form uses optical scanners capable of reading printed or written forms, then a paper statement or other form can be generated by the system and used as a turnaround document. Output that later comes in as input pre-printed on the form, but the computer prints variable information on the document. Layout of printed output. An output layout is the arrangement of items on the output medium. When analysts design an output layout, they actually build a sample of the actual report or document as it will appear after the system is in operation. The layout should show the location and position of the following: all variable information, item details, summaries and totals, control breaks, separators. All pre-printed details, headings, document names and titles, corporate name and address, instructions, notes and comments. The form layout is a blueprint that guides the construction of programs later in the development process. Guidelines for designing printed output. Reports and documents have to be designed to be read from left to right and from top to bottom. The most important items should be easiest to find. Roll number in a marks cross list is most important, hence it is placed on the leftmost column. All pages should have a title and page number and should show the date on which the output was generated. All columns must be labeled. Abbreviations must be avoided. Some organizations specify standards that guide design practices in addition to the above guidelines. Designing visual display output. The principles of good design discussed for printed outputs also apply to output that is shown on workstations or video display terminals. The only difference being the lesser space one gets to work on in the screen output design as compared to the printed output. Each display page is commonly called a screen or panel. Its layout can either ease or impede its use. Designing a layout begins by verifying the characteristics of the display screen. These include physical dimensions of the screen, number of rows and columns of data that can be displayed, degree of resolution high, medium, low, number of colors available, monochrome, true color, 3 color, 8 color, etc. Methods of highlighting, underline, bold, blinking, alternate intensities. Methods of intensity control. Visual display screens have 80 columns with 24 or 25 lines. Point of sale displays and portable computers has smaller dimensions. Screen sections. It is helpful to divide the screen into sections that are consistently used in the same way to present information, identifications, and messages to the users. It shows the areas of a display that stand out the most, including the top line, center section, and 4 corners. Experience has proved that the upper left-hand corner is the most visible section. Good screen design makes the possible use of these areas. In designing output screens, we need areas for heading and titles, content of the display, message and instructions, and sometimes explanations for information in the report. User interface design. In this video, we are going to see about user interface design. User interface design is a front-end application view to which user interacts in order to use the software. User can manipulate and control the software as well as hardware by means of user interface. Today, user interface is found at almost every place where digital technology exists, right from computers, mobile phones, cars, music players, airplanes, ships, etc. User interface is part of software and is designed such a way that it is expected to provide the user insight of the software. UI provides fundamental platform for human-computer interaction. UI can be graphical, text-based, audio, video-based, depending upon the underlying hardware and software combination. UI can be hardware or software or a combination of both. Software becomes more popular if its user interface is attractive, simple to use, responsive in short time, clear to understand, consistent on all interfacing screens. UI is broadly divided into two categories: command line interfaces, graphical user interface. Command line interface (CLI). CLI has been a great tool of interaction with computers until the video display monitors came into existence. CLI is first choice of many technical users and programs. CLI is a minimum interface where software can provide to its users. CLI provides a command prompt, the place where the user types the command and feeds to the system. The user needs to remember the syntax of command and its use. Earlier CLI were not programmed to handle the user error effectively. A command is a text-based reference to set of instructions which are expected to be executed by the system. There are methods like macros, scripts that make it easy for the user to operate. CLI uses less amount of computer resource as compared to GUI. CLI elements. A text-based command line interface can have the following elements: command prompt. It is text-based notifier that is mostly shows the context in which the user is working. It is generated by the software system. Cursor. It is a small horizontal line or a vertical bar of a height of the line to represent position of character while typing. Cursor is mostly found in blinking state. It moves as the user writes or deletes something. Command. A command is an executable instruction. It may have one or more parameters. Output on command execution is shown in line on the screen. When output is produced, command prompt is displayed on the next line. Graphical user interface. In this video, we are going to see about graphical user interface. Graphical user interface provides the user graphical means to interact with the system. GUI can be a combination of both hardware and software. Using GUI, user interprets the software. Typically, GUI is more resource-consuming than that of CLI. With advancing technology, the programmers and designers create complex GUI designs that work with more efficiency, accuracy, and speed. GUI elements. GUI provides a set of components to interact with software or hardware. Every graphical component provides a way to work with the system. A GUI system has following elements such as Window. An area where contents of application are displayed. Contents in a window can be displayed in the form of icons or lists if the window represents file structure. It is easier for a user to navigate in the file system in an exploring window. Windows can be minimized, resized, or maximized to the size of the screen. They can be moved anywhere on the screen. A window may contain another window of the same application called child window. Tabs. If an application allows executing multiple instances of itself, they appear on the screen as separate windows. Tabbed document interface has come up to open multiple documents in the same window. This interface also helps in viewing preference panel in application. All modern web browsers use this feature. Menu. Menu is an array of standard commands grouped together and placed at a visible place, usually top, inside the application window. The menu can be programmed to appear or hide on mouse clicks. Icon. An icon is a small picture representing an associated application. When these icons are clicked or double-clicked, the application window is opened. Icon displays application and programs installed on a system in the form of small pictures. Cursor. Interacting devices such as mouse, touchpad, digital pen are represented in GUI as cursors. On-screen cursor follows the instructions from hardware in almost real time. Cursors are also named as pointers in GUI systems. They are used to select menus, windows, and other application features. Application-specific GUI components. A GUI of an application contains one or more of the listed GUI elements. Application window. Most application windows use the constructs supplied by operating systems, but many use their own customer-created windows to contain the contents of application. Dialog box. It is a child window that contains message for the user and request for some actions to be taken. For example, application generates a dialog to get confirmation from user to delete a file. Text box provides an area for user to type and enter text-based data. Buttons. They imitate real-life buttons and are used to submit inputs to the software. Radio button displays available options for selection. Only one can be selected among all offered. Checkbox functions similar to list box. When an option is selected, the box is marked as checked. Multiple options represented by checkboxes can be selected. List box provides a list of available items for selection. More than one item can be selected. Other impressive GUI components are sliders, combo box, data grid, drop-down list, user interface design activities. There are a number of activities performed for designing user interface. The process of GUI design and implementation is like SDLC. Any model can be used for GUI implementation among waterfall, iterative, or spiral model. A model used for GUI design and development should fulfill these GUI-specific steps. GUI requirement gathering. The designers may like to have a list of all functional and non-functional requirements of GUI. This can be taken from user and their existing software solution. User analysis. The designer studies who is going to use the software GUI. The target audience matters as the design details change according to the knowledge and competency level of the user. If user is technical savvy, advanced and complex GUI can be incorporated. For a novice user, more information is included on how-to of software. Task analysis. Designers have to analyze what task is to be done by the software solution. Here in GUI, it does not matter how it will be done. Tasks can be represented in hierarchical manner, taking one major task and dividing it further into smaller subtasks. Tasks provide goals for GUI presentation. Flow of information among subtasks determines the flow of GUI contents in the software. GUI design and implementation. Designers, after having information about requirements, tasks, and user environment, design the GUI and implements into code and embed the GUI with working or dummy software in the background. It is then self-tested by the developers. Testing. GUI testing can be done in various ways. Organization can have in-house inspection, direct involvement of users, and release of beta version, or few of them. Testing may include usability, compatibility, user acceptance, etc. GUI Implementation Tools. In this video, we are going to see about GUI Implementation Tools. GUI Implementation Tools provide a powerful array of GUI controls. For software customization, designers can change the code accordingly. There are different segments of GUI tools according to their different use and platform. Examples are mobile GUI, computer GUI, touchscreen GUI, etc. Here is a list of few tools which come handy to build GUI. Fluid, App Inventor for Android, Lucid Chart, WaveMaker, Visual Studio. User Interface Golden Rules. The following rules are mentioned to be the golden rules for GUI design. Strive for consistency. Enable frequent users to use shortcuts. Offer informative feedback. Design dialog to yield closure. Offer simple error handling. Permit easy reversal of actions. Support internal locus of control. Reduce short-term memory load. Strive for consistency. Consistent sequences of actions should be required in similar situations. Identical terminology should be used in prompts, menus, and help screens. Consistent commands should be employed throughout. Enable frequent users to use shortcuts. The user's desire to reduce the number of interactions increases with the frequency of use. Abbreviation function keys, hidden commands, and micro facilities are very helpful to an expert user. Offer informative feedback. For every operator action, there should be some system feedback. For frequent and minor actions, the response must be modest, while for infrequent and major actions, the response must be more substantial. Design dialog to yield closure. Sequences of actions should be organized into groups with a beginning, middle, and end. The informative feedback at the completion of a group of actions gives the operators the satisfaction of accomplishment, a sense of relief, the signal to drop contingency plans and options from their minds, and this indicates that the way ahead is clear to prepare for the next group of actions. Offer simple error handling. As much as possible, design the system so the user will not make a serious error. If an error is made, the system should be able to detect it and offer simple, comprehensible mechanisms for handling the error. Permit easy reversal of actions. This feature relieves anxiety since the user knows that errors can be undone. The easy reversal of actions encourages exploration of unfamiliar options. The units of reversibility may be a single action, a data entry, or a complete group of actions. Support internal locus of control. Experienced operators strongly desire the sense that they are in charge of the system and that the system responds to their actions. Design the system to make users the initiators of actions rather than the responders. Reduce short-term memory load. The limitation of human information processing in short-term memory requires the displays to be kept simple, multiple page displays be consolidated, window motion frequency be reduced, and sufficient training time to be allotted for codes, mnemonics, and sequences of actions. Data storage and introduction. In this video, we are going to see about data storage and introduction. If the input and output designs are finalized, the next step is to design the storage, which involves organizing the data according to application requirements. The organization of data in files depends on the nature of data usage and response requirements. All information systems create, modify, delete, and read data. This data is stored in files and databases. Any set of accessible records in a computer system may be described as a file. Database is an integrated approach to data management. It is basically a collection of interrelated files. For example, a student database might contain student details that are linked to their corresponding course and fee records. There is a fundamental difference between file and database environment. In the file environment, data storage is built around the applications that will use the files, whereas in the database environment, applications are built around the integrated database. There are various advantages and disadvantages of each environment. Basic file terminology. A byte is an arbitrary collection of 8 bits that represents a character. It is the smallest addressable unit in today's computer. An attribute of an object can be described by combining one or more bytes into a data item. A data item is also referred to as a field. For example, if the object is a student, it can have the following attributes: name, age, class, or rank. A field is actually a physical space on the storage device, whereas a data item is the data stored in the field. A collection of data items related to an object constitutes a record. A school student has a record with his or her name, address, age, class, and identification number as a unique key. The student's identification number could be used as an identifier for processing the record. While talking of record design, we should know the difference between logical and physical records. A logical record maintains a logical relationship among all the data items in the record. It is the user's or the program's view of the data. As distinct from this, a physical record shows the way data are recorded on a storage medium. For example, if a programmer wishes to access a file in a particular sequence, is not aware of the physical map on the disk, but the software presents the logical records in the desired sequence. This is a distinctive feature of the database design. A file is a collection of related records. There is no restriction on the size a file can grow to. It is limited only by the size of memory or the storage medium. File organization is determined by the following two characteristics: activity, volatility. File activity indicates the percentage of actual records processed in a single run. If fewer numbers of records are accessed at any specified time, the file should be organized on disk for direct access. Contrary to this, if a large number of records are affected regularly, then storing the file on tape for sequential access would be more efficient and cost-effective. File volatility considers the properties of record changes. File records requiring frequent changes are highly volatile, where the disk media would be more effective than tape. Consider the railway reservation system and the high volatility that results due to cancellations, additions, and other transactions, compared to traditional payroll, which does not require frequency changes. Database is at the highest level in the data organization hierarchy. It is a set of interrelated files for real-time processing. The data stored in the database can be accessed by several users simultaneously, and it is basically comprises of data that can be used for problem solving. Types of files. Files can be categorized on the basis of the records they store and maintain and to describe the kind of computer processing function they support. The most common types of files are as follows. Master file. These are important files in a business application as they contain records that are relatively permanent and are essential for maintenance of the organization's business. Thus, once a record has been fed, it remains in existence throughout the life of the system. Some of the examples of the master files are files containing student, customer, and employee data. Transaction file. Transaction file contains data that describe business events. It can also be referred to as an input file. The data describing these events normally have a limited lifespan. The transaction file is a temporary file used for two purposes. One is to accumulate data about or events as they take place and produce summary reports. Secondly, it helps in updating master files to reflect the result of current transactions. The transaction refers to any business event that affects the organization and about which data are captured. The examples of transaction files include sales, invoices, and registrations. Report file. Report files are accumulated contents of individual output reports or documents generated by the information systems. Report files contain the processed output data. Report files are created by the system where many reports are produced by the system, but only a few reports get printed due to availability of printer. Such situation arises when the system carries out input, processing, and out tasks simultaneously. In this case, system writes the report contents on a disk where it remains until it can be printed. Archival file. Archival file contains master and transaction file records that have to be removed from online storage. It keeps a copy of computer-held data at a particular point of time. Records in archival file are merely moved from online storage to offline storage. It is basically used for long-term storage of information about the organization's business for statutory and strategic reasons. File organization. In this video, we are going to see about file organization. File organization helps in making the records easily accessible for processing. As has already been discussed, a file should be designed in accordance with the activity and volatility of the information and the nature of the storage media and devices. Other points to consider are storage cost, access requirements, file privacy, integrity, security, and confidentiality. There are 4 alternative methods of organizing files: serial, sequential, indexed sequential, and direct access. Serial file organization. This is the simplest organization of records within a file. In serial organization, the file is created by placing one record after another. The approach this design follows is that of reading one record after another without introducing any search delay. In the serial organization, records cannot be inserted in between, they can only be added at the end of the file. In a sequential file, all records are stored by position. In reading a serial file, the system always starts at the beginning of the file and reads its way up to the record, one record at a time. For example, if a particular record happens to be the 5th one in file, the system starts at first one and reads ahead one record at a time until the 5th one is reached. Advantages of serial file organization. Serial files are simple to understand and design. These files require relatively inexpensive I/O media and devices. Serial files are efficient and economical if activity rate is high. Disadvantage of serial file organization. Even for a single record, entire file must be processed. Records cannot be added to the middle of the file. Sequential file organization. In a sequential file, records are arranged into ascending or descending order according to a key field. The key field may be alphabetic, numeric, or a combination of both. Searching in a sequential file. To search a specific record in a sequential file system, do not use a physical record key. For this purpose, system assigns the value of the particular record as a search key. For example, when searching a particular student number, say 101, the system starts reading from the first record and compares the search key 101 with it. If they do not match, the process is repeated until the student number matches the search key. Advantages of sequential file organization. These are very logical to design and understand. This organization is fairly efficient for a whole variety of applications. Supports very efficient programming. Disadvantages of sequential file organization. On the average, half of the total number of records needs to be searched for locating any particular record. In sequential files, data redundancy is typically high since the same data may be stored in several files sequenced on different keys. Indexed sequential file organization. Indexed sequential file organization makes use of an index for accessing records stored in the system. To search a record, when the storage address is unknown, it is necessary to scan all the records. However, using index search is faster since it takes less time to search an index as compared to an entire file of data. An index file is a separate file from the main file to which it pertains. Each record in the index file contains a record key and a storage address. To find a particular record, the index is first searched to find the key of the desired record. Indexed non-sequential file organization. In this file organization, an index contains record keys for each record in the master file and the storage location for the corresponding master file. The arrangement of records in the master file is not by order. This type of organization is called indexed non-sequential file organization. Indexed sequential file organization. In an indexed sequential file organization, groups of records are stored in blocks with the capacity for a specified amount of data. Searching a record requires only the highest or lowest key value for any record in the block. Since each block in this type of organization is always in sequential order, an index entry for every record is longer necessary. It requires only one index entry for each block. The Index Sequential Access method (ISAM) uses the highest key value to depict the indexed file organization. For example, if program wants to find the record with key value E316, first it accesses the index starting with the beginning record and compares the search key with E112. Since E316 is higher than the highest value E112 of block 1233, the program starts to search in the next index record and compares the search key. Since the search key E316 is lower than the highest key value E319 of this block, the program starts reading the records at address 1234. It compares the key with the records in this block, starting with the first record in this block. First, it compares E316 with E302, then with E303, and so on until it finds E316. Here, the record E316 is the 13th record in block 1234. Advantages of indexed sequential file organization. The indexed file organization permits the economical and efficient use of sequential processing techniques when the activity rate is high. This organization also provides quick access to records in a relatively efficient way. Disadvantages of indexed sequential file organization. Indexed file organization is less efficient in the use of storage space than some other file organizations. It requires relatively expensive hardware and software resources. Processing is occasionally slow. Inverted list organization. This can be treated as a special case of indexed sequential file organization. The inverted list organization maintains an index just like the indexed sequential storage method. It is in the index level and record storage that the two methods differ. For a given key, the indexed sequential method has multiple indexes, whereas the inverted list method has a single index type of key for each key type. Records are not compulsorily stored in a particular sequence in an inverted list. They are stored in the data storage area, but indexes are updated for the record keys and location. The inverted lists are ideal for applications that require specific data on multiple keys. Direct access organization. The disadvantage of sequential files, that is, to access records in a sequential manner only, is overcome by the direct file organization. In the direct file organization, records are stored randomly in the file. Records are not required to be in sequence because they are updated directly and rewritten back in the same place on disk. New records are added at the end of the file or inserted at specific locations based on software commands. In direct file organization, all records are stored by key at address rather than by position. If the program knows the record key, it can derive the location address of a record and access it independently of every other record in the direct file. Records are retrieved by addresses that indicate their disk locations. An address is used for finding a record, for linking records, or for setting relationships. Addresses are of two types: absolute, relative. Advantages of direct file organization. Using direct file organization, the time taken for searching the transactions can be minimized. It is possible to update several files as a result of single transaction. The disadvantages of direct file organization. As compared to sequential organization, direct file organization may be less efficient in using the storage space. Insertion and deletion of records is more difficult than with sequential file organization. Direct file organization requires relatively expensive hardware and software. Pros and cons of files. One advantage of files is in terms of processing speed, that is, they can be optimized for the access of application, but at the same time, they can rarely be optimized for shared use by different applications. Disadvantages of file systems are also significant. One such disadvantage of files is their non-scalability and inflexibility. Secondly, duplication of data items in multiple files is normally considered as a primary advantage of file systems. Database and its objectives. In this video, we are going to see about database and its objectives. The gradual separation of data and programs has been one of the significant developments in data processing since computers were put to use in commercial activities. Earlier, the database was used distinctively by large corporations with mainframes. These days, it is seen as backbone of MIS and is available for all sizes of computers. Before the database concepts evolved, there was conventional file environment with no data integration or sharing of common data across applications. In a database environment, common data are accessible to several users. Instead of each program or user managing its own data, data across applications are shared by authorized users with the database software managing the data as an entity. A program now requests data through the Database Management System (DBMS), which manages data sharing. The database aims at handling organizational data as an integrated whole. A database is a general collection of interrelated data stored with minimum redundancy and used by a variety of users. The general objective is to make data access easy, quick, inexpensive, and flexible for the user. In particular, it has following features. Items of data occur only once, that is, redundancy is eliminated. The data is independent of any one program. The data is usable by many users. In a database design, several specific objectives are taken into account. Elimination of redundant data. Redundant data often causes system to give conflicting information as version of the same data is in different phases of updating. A unique aspect of database design is storing data only once. This controls redundancy and improves system performance. User-friendliness. Generally, the database packages are easy to learn and use. This forms one of the major advantages of databases. In addition, a database can be altered without interfering with set ways of using the data. Data independence. One of the prime objectives of database is to eliminate the need to rewrite application programs in case hardware or storage procedures are altered or new data is added. The database should adapt to the new setup without rewriting programs. Cost effectiveness. It is imperative to use, store, and modify data at low cost. The rising cost of software and programming necessitates simpler programming and easier software enhancement. Accuracy and integrity. The accuracy of a database ensures that the quality and content of data remains constant. Integrity procedure detects and controls data inaccuracies as they take place. Recovery from failure. As many users have an access to a database, the system must recover quickly in case of failure, and that too with no loss of transaction data. This objective also facilitates data accuracy and integrity. Privacy and security. Adequate security measures must be taken to prevent unauthorized access to data. A log of database activities should be maintained and closely monitored to keep track of irregular occurrences. Performance. Response time to user requests should be satisfactory. How satisfactory the response time is depends on the nature of the user database interaction. Database design. In this video, we are going to see about database design. Database design enables us to represent the real-world entities in a form that can be processed by the computer. The structure of a database is based on the data model, a collection of conceptual tools for describing data, their relationships, semantics, and consistency constraints. The data model gives us methods to capture the static and dynamic attributes of real entities. For example, if we want to capture the attribute of an employee, then we can get his or her details like name, age, sex, address, telephone number, department, designation, etc. The main point of concern in collecting the details is that how much information should be collected about an entity and represented in database format for it to be significant and accurate and above all useful from the application point of view. For developing a good database design, it is essential to understand the meaning of information and the intended use of the information stored representation within the computer system. On analyzing the use of information in the application, we can ascertain its format and representation in the computer system or database. It is only during the determination of the information requirements of an application that the usefulness of the data becomes evident. The criticality of the information redundancies, usefulness of information, all are considered during this phase. It is good to collect and analyze the information about the real-world applications before starting the database design. A good database design has an underlying model, a database design model, which has the following advantages. It helps in representing the real-world objects in a computer-usable form. It also helps in representing associations and relationships among the real-world objects. It defines how the objects interact in the application. It allows the database designer to capture static and dynamic organization and flow of information within a host enterprise. It helps in improving the maintainability, scalability, and reliability of the system. The selection of database architectural models largely depends on the determination of the information requirements for an application. Requirements analysis. The database design team must initially determine the scope of the requirements of the application set before designing the database. Requirements analysis involves close examination of the problem and includes human factors of the application, application's functionality, description of the information managed and used by the application, determination of the interfaces to an application, identification of the resource requirements, identification of the security requirements and mechanisms, description of the quality, reliability, performance, and operational aspects of the application. For all the requirements listed above, the analyst must check the collected data and ensure its usefulness for the application. The information must be analyzed for correctness, consistency, completeness, realistic representation, need, correctness. The information should represent the real-world system correctly, consistency. The definition of an entity must cover all possible values that it may take. All the constraints of the real-world entity must be adequately depicted. Completeness. The defined entity should be complete, that is, no attribute should be missing. All the relevant attributes of the real-world entity should be included in the model. Realistic representation. The representation of the entity must be realistic. Need. The usefulness of the information for the application should be established. Information modeling. Information modeling aims at identifying the major entities and their interrelationships in an application and modeling them in a target database schema model. A real-world system might have a number of entities, but all may not be significant for the application. So the most important objective of information modeling is to identify those entities that are really important and useful for the application. The information collected during the requirements analysis stage helps the database designer to define the major entities to be modeled in the database. Introduction to case tools. In this video, we are going to see about introduction of case tools. Computer-aided software engineering case refers to the use of computer-based systems or automates or supports the analysis and design of systems and facilitates the translation of system models into application programs. Case, that is computer-aided software engineering tools, have evolved over the last couple of decades with the promise of improving software quality and productivity. Currently, in the software development industry, a variety of case tools are employed throughout the life cycle to replace tasks with automated support and standardization. Case tools support software engineering activities within a software engineering process. Model-based analysis and design tools are a special class of case tools which help to develop correct software. Case tools offer many benefits for developers building large-scale systems. As changing user requirements continue to drive system complexity to new levels, the case tools ease the task by taking to a level where architecture and design become more apparent and easier to understand and modify. The larger a project, the more important it is to use a case technology. As developers interact with the portions of a system designed by their colleagues, they must quickly seek a subset of classes and methods and develop an understanding of interfacing with them. Likewise, management must be able, in a timely fashion and from a high level, to look at a representation of design and understand what is going on. For these reasons, case tools give us a way of representing complex systems. Features of case tools. In this video, we are going to see about features of case tools. Software development is a difficult and challenging task. Case tools reduce the amount of effort and time required to produce a work product or accomplish some project tasks. Case tools constitute application development environments (ADE), facilitating performance of certain front-end tasks, diagramming, and documentation and modeling through automated support and totally automatic back-end tasks like coding and testing. Case technology supports forward and reverse engineering. Forward engineering. The system analyst draws system model and then the resulting models are subsequently converted into program code. Reverse engineering. The case tool reads the existing program code and transforms that code into a representative system model. The automated case tools facilitate designers and developers in numerous ways. Automated software tools make the development of information systems easier for the systems analyst. Case tools support or automate activities throughout the system's development lifecycle (SDLC). Increased productivity, improved overall quality of systems, use of case in organizations. The main purpose of case is to facilitate a single design philosophy within an organization. Given below are the ways in which the case can provide support for most of the system's development lifecycle activities. Project identification and selections. Case can be used for planning matrices and enterprise data model. Project initiation and planning. Tasks like developing project schedules and estimating system size can easily be done with the help of case tools. Analysis. Case can be put to use in this phase for preparing data flow diagrams or state transition diagrams. Design. In this phase, case facilitates in normalizing relations and designing forms and reports. Implementation. Installation schedule and code can be had for this phase from case. Maintenance. Case facilitates this phase by providing version control and specification changes. Application development environment and the placing of case tools in the same. Case improves speed and system quality. Majority of organizations adopt case to improve speed and quality of systems development process. The factors that inhibit widespread deployment and case tools are cost, return on investment, productivity bottlenecks. Objectives of case. Case tools offer a graphical facility to generate quality output which can be quickly and effectively produced and amended. Other than improving the quality of systems developed, case tools support organizations in the following ways: by increasing speed of development and design, by improving testing process through automated checking, by improving integration of development activities via common methodologies, by improving quality and completeness of documentation, by helping standardize the development process, by improving project management, by simplifying program maintenance, by promoting reusability. Components of case tools. Automated case tools support a wide variety of system development lifecycle activities. Case tools can be classified in the following three categories on the basis of the SDLC activities they support. Upper case. Case tools designed to support the information planning and the project identification and selection, project initiation and planning, analysis and design phases of the system development lifecycle. Lower case. Case tools designed to support the implementation and maintenance phases of the system development lifecycle. Cross lifecycle case. Case tools designed to support activities that occur multiple phases of the system development lifecycle. The relationship between case tools and the SDLC. Case-based versus traditional systems development. In traditional systems development, most of the time was spent on coding and testing. Every minor software change required the system analyst to make the amendments in the documentation and specification documents to reflect the changes. Case-based approach, on the contrary, restricts the role of systems analyst to maintaining the design documents, as most other aspects are automatically taken care of. Case-based system development emphasizes on analysis and design, provides rapid interactive prototyping, facilitates automatic code generation, provides automatic documentation generation, facilitates automatic design checking, helps in maintaining design specifications. Types of case tools. This classification of case tools is based on the functionality they provide. Diagramming tools, computer display and report generator, analysis tool, documentation generators, code generators. Case diagramming tools. A good diagram is a powerful medium to facilitate communication across teams and the organization. Case diagramming tools enable you to depict a system and its various components diagrammatically. Here we list some of the best tools that will help you generate clear and useful diagrams. Visio Professional 2002, Visio Enterprise 2000, Visio Standard 2002. Some of the features of these tools are listed below. Enable representation of a system and components visually. Effective for representing process flow, data structure, and program structure. Several types of diagrams that can be drawn are data flow diagrams (DFD), functional hierarchy diagrams, and entity relationship diagrams. Case, form, and report generator tools. Form and report generators are case tools that support the creation of system forms and reports in order to prototype how system will appear to users. First, to create, modify, and test prototypes of computer display forms and reports. Second, to identify which data items to display or collect for each form of report. Example of such tool includes Oracle's Form Designer. Case analysis tools. Analysis case tools enable automatic checking for incomplete, inconsistent, or incorrect specifications in diagrams, forms, and reports. The process modeling and data modeling tools used for analysis are out of balance DFD and case repository respectively. It enables a software designer to create models of the system to be built. Integrated case, iCase. Integrated case or iCase is an automated systems development environment that offers various tools to create diagrams, forms, and reports. It provides analysis, reporting, and code generation facilities. iCase tools seamlessly share and integrate data across and between various case tools. The repository is the central place or a nucleus of an iCase environment and is used for the smooth integration of the tools employed during the various SDLC phases. Other development tools. Documentation tools. Desktop publishing and document production tools support nearly every aspect of software development project. Examples are Rational Rose and Vista. Interface design tools. Interface design tools support creation of interface controls such as menus, toolbars, buttons, device contexts, icons, etc. These tools automate the process of the system development to a stage of analysis and design. Database management tools. These tools support creation of project databases and are used to create database repository. Prototyping tools. These tools help in creation of a data design coupled with both screen and report layouts. They also enable software engineers to define screen layout rapidly for interactive applications. Quality assurance tools. These are metric tools used to audit source code to determine compliance with language standards. Major focus of such tools is to ensure software quality. Code generators. Automated code generation is not a new concept, although it has seen relatively little recognition until recently. A code generator reads your project metadata, for example the database model, and writes well-formed source to a specific set of design patterns. Integration and testing tools. Various categories of tools are used for integration and testing of software. Some of these are cross-functional tools, static measurement tools, dynamic measurement tools, test management tools, visual and emerging development tools. Visual and emerging development tools enable developers to quickly create user interfaces. Some of the popular tools include Microsoft Visual Studio, Delphi, Power Builder, Code Fusion. Advantages and limitations of case tools. In this video, we are going to see about advantages and limitations of case tools. Case tools offer a number of benefits during requirement analysis, application prototyping, and iterative development process. Various benefits of using this technology are as follows: easy revision of system description and graphic representations, support of system prototyping through the capability to change specification and determine the impact of alternative features of system performance. Some case tools have the capability to produce working source code for the application. Case tools also provide maintenance support as a result of storage of system specifications in a central information repository. Limitations of case tools. The limitations of case tools are significant. Major limitations are as follows: absence of standard levels of methodology support, limited functions supported, conflicting use of diagrams, human tasks remain critical. Awareness about some commercial case tools. In this video, we are going to see about awareness about some commercial case tools. Case technology is the automation of step-by-step methodologies for software and system development. Case tools are characterized by the stage or stages of software development lifecycle on which they focus. Since different tools covering different stages share common information, it is required that they integrate through some central repository system, that is data dictionary, to have a consistent view of such information. In phases of software development lifecycle integrated through a central data dictionary. Case tools are used in many ways in our organizations. Case tools can be broadly classified into these broader areas. Diagram tools. These tools are used to represent system components, data, and control flow among various software components and system structure in a graphical form. For example, flowchart maker tool for creating state-of-the-art flow charts. Process modeling tools. Process modeling is the method to create software process model, which is used to develop the software. Process modeling tools help the manager to choose a process model or modify it as per the requirement of software product. For example, EPF Composer. Project management tools. These tools are used for project planning, cost and effort estimation, project scheduling, and resource planning. Managers have to strictly comply project execution with every mentioned step in software project management. Project management tools help in storing and sharing project information in real time throughout the organization. For example, Creative Pro Office, Track Project, Basecamp. Documentation tool. Documentation in a software project starts prior to the software process, goes throughout all phases of SDLC, and after the completion of the project. Documentation tools generate documents for technical users and end users. Technical users are mostly in-house professionals of the development team who refer to system manual, reference manual, training manual, installation manuals, etc. The end user documents describe the functioning and how-to of the system, such as user manual. For example, Doxygen, Dr. Explain, Adobe RoboHelp for documentation. Analysis tools. These tools help to gather requirements, automatically check for any inconsistency, inaccuracy in the diagrams, data redundancies, or erroneous omissions. For example, Accept 360, Acampa, Case Complete for requirement analysis, Visible Analyst for total analysis. Design tools. These tools help software designers to design the block structure of the software, which may further be broken down into smaller modules using refinement techniques. These tools provide detailing of each module and interconnections among modules. For example, animated software design. Configuration management tools. An instance of software is released under one version. Configuration management tools deal with version and revision management, baseline configuration management, change control management. Case tools help in this by automatic tracking, version management, and release management. For example, Fossil, Kit, Accu, REB. Change control tools. These tools are considered as a part of configuration management tools. They deal with changes made to the software after its baseline is fixed or when the software is first released. Case tools automate change tracking, file management, code management, and more. It also helps in enforcing change policy of the organization. Programming tools. These tools consist of programming environments like IDE, Integrated Development Environment, inbuilt modules library, and simulation tools. These tools provide comprehensive aid in building software product and include features for simulation and testing. For example, C Scope to search code in C, Eclipse. Prototyping tool. Software prototype is a simulated version of the intended software product. Prototype provides initial look and feel of the product and simulates few aspects of actual product. Prototyping case tools essentially come with graphical libraries. They can create hardware-independent user interfaces and design. These tools help us to build rapid prototypes based on existing information. In addition, they provide simulation of software prototype. For example, Serena Prototype Composer, Mockup Builder. Web development tools. These tools assist in designing web pages with all allied elements like forms, text, script, graphic, and so on. Web tools also provide live preview of what is being developed and how will it look after completion. For example, Fontello, Adobe Edge Inspect Foundation 3 brackets. Quality assurance tools. Quality assurance in a software organization is monitoring the engineering process and methods adopted to develop the software product in order to ensure conformance of quality as per organization standards. QA tools consists of configuration and change control tools and software testing tools. For example, SOAP Test, Apps Watch, JMeter. Maintenance tools. Software maintenance includes modifications in the software product after it is delivered, automatic logging and error reporting techniques, automatic error ticket generation, and root cause analysis are few case tools which help software organization in maintenance phase of SDLC. For example, Bugzilla for defect tracking, HP Quality Center.